Hi and welcome. I'm trying to learn biochemistry. Today, solutions, colloids and suspensions. And after we've done that, we're gonna do body central training. And if you participate in the body central training, then is that idea. And this is part 2 of the solutions, colloids and suspensions. So, in a suspension, we're talking about blood. Now, in a suspension, by contrast, the suspended material may mix with a liquid or suspending medium for some time, but eventually it will settle out. Blood is an example of a suspension. When freshly drawn from the body, blood has an even reddish color. After it sits for a while in a test tube, the top layer appears pale yellow. This is the liquid portion of blood called plasma, which is both a solution of ions and other small solutes and a colloid due to the presence of plasma proteins. Red blood cells that have settled out of a suspension drift to the bottom of the tube, making the lower layer look red. So basically we're talking about 3 different things. There are solutions and where everything mixes completely up. We had as an example, I think it was salt water. Sweat, for example. The salt is completely salted up, or dissociated, I think it's called, in the water. It's completely in the solute away. So the whole thing is called a solution because the solute, which is the salt, has in the solvent, which is the water, completely dissolved. And now a colloid where it is not completely dissolved. Milk, for example, milk where the milk proteins they are visible, and therefore it is a colloid because they have not completely mixed up, I think is it. And now, is it both? Milk is both. Milk is a solution and a colloid. A colloid because the milk proteins have not completely mixed, but a solution also because other things inside of the milk have completely mixed. And now suspension, I read that is where things are basically sinking down to the bottom over time. Whereas if you take blood, as for example here, it is even at the beginning if it's freshly drawn, and if you let it stand, then the hemoglobin sinks down to the bottom, and at the top layer there's the plasma, so it is a suspension because the things have sunk down. That does not happen with milk or something, with a colloid. But it's also a solution because some things in the plasma have completely dissolved completely in the plasma, but also a colloid because some things inside the plasma proteins, therefore the plasma is not just a solution. So blood is a solution because there are some things in the plasma which have completely dissolved. It is a colloid because the plasma proteins inside of the plasma and the top of it are there and they are scattering light, they have dissolved, but the solute particles in a colloid are large enough to scatter light, just as water droplets in fog. Is that a reason? So they have not dissolved to the point where they are invisible. That is more or less what I understand. But it's also a suspension because the hemoglobin sinks down to the bottom. The plasma proteins don't sink down to the bottom of the plasma part. They stay completely mixed up there in the plasma part, but are visible, so they are not completely new bound together. Now, the concentration of a solution may be expressed in several ways. 2 common ways are by percent, which gives the relative mass of a solute found in a given volume of solution, and in units of moles per liter, which relate to the total number of molecules which relates to the total number of molecules in a given volume of solution. What we're saying, we can say in a percentage, we can say the amount of salt in. No, we had it recently done in maritime studies. There was said that the Atlantic Ocean has a salt amount of 34%. I think that's incredibly high. But more or less, as I understand it, you could say the solvent, would it be? No, the solute. The solute is the water, and the 30% of solute are the salt in the ocean. Now that is the first thing, and the other idea is just to say the whole number of molecules in it, of this other. Let's read it one sentence again. In a solution, we get it. That is the whole thing where something has mixed up together. A mixture is a combination of elements or compounds that are physically blended together but not bound by chemical bonds. In a solution, a substance called the solvent dissolves into another substance called the solute. Is it now a difference between mixture and solution? Whatever, let's make the other thing here. As in a solution, a substance called the solvent dissolves another substance called the solute. That is totally wrong, and I really promise with it right now. A solvent dissolves another substance called the solute. The solvent itself is doing the work of dissolving of the thing put into it, the solute. So the salt is the solute, and the solvent is the water. For example, your sweat is a dilute solution of water, plus small amounts of salt, and that is the solute. Solute is the thing put in, basically, the salt, and solvent is the water, the bigger part. And it can be given in molecules. How many molecules are in total number? A mole is the amount in grams of any substance that has a mass equal to the combined atomic masses of all its atoms. For example, 1 mole of the element chlorine with atomic mass of 35.45 is 35.45 grams, and 1 mole of a salt, sodium chloride, is 58.44 grams. 22.99 for natrium and 35.45 for chloride, just as a dozen for chloride. Okay, they're saying chlorine has 35 and natrium or sodium, whatever, the other thing has 58, has 22, and therefore the thing mixed together has 58. I think that's what we're doing. That makes sense. Must be it. Chlorine 35 and the other thing has 23, together have a 58. Just as a dozen always means 12 of something, a mole of anything has the same number of particles, 6 point, I don't know how to say, times 10 to the 20 power of 23. This huge number is called the Avogadro's number. Thus, measures of substances that are stated in moles tell us about the number of atoms, ions, or molecules present. This is important when chemical reactions are occurring because each reaction requires a set number of atoms of specific elements. That means that is the amount of atoms or of something else in it. It is the amount of it. So we're saying 1 mole of chlorine weighs 35 grams, and 1 mole of sodium chloride 58. That makes it obvious that it's not about weight, so it is about the amount of molecules in it. And then we're saying there's 1 mole in it, when there are 6023 to the power of 23 times of this atom of salt in it. It doesn't matter how heavy natrium or chloride or sodium carbonate is, they are saying there's 1 mole in it, so there's 6, I can't read it, either 6.0.23 or 6000 times 10. I think it was 6.023, whatever, with this number of molecules in it. And it doesn't matter if it's how heavy they are saying they are 6.023 to the power of 10 times 10 to the power of 23 atoms of salt in it. Percent mass per volume, number of grams of substance per 100 milliliters of solution. To make a 10% natrium chloride, I'm going to say it's, but I don't know if it's natrium chloride, solution, take 10 grams of natrium chloride and add enough water to make a total of 100 milliliters of solution. To make a 1 molar solution of natrium chloride, dissolve 1 mole of natrium chloride, which are 58.44 gram, in enough water to make a total of 1 liter of solution. We're saying here a 1 molar solution equals 1 mole of a solute in 1 liter. Did we set it here also? Yes, per liter. Moles per liter. MOL, I think. Moles per liter. The molarity. Okay, that makes totally sense. It can be said in percentage. When it would be said we have 58% in it of natrium chloride, and that would mean 58 gram of 1000, so 0.5, I think, percent. Would it be then? Yes, 0.58% heavy natrium chloride in our 1 liter of water, or we could say we have 1 mole of sodium chloride, of natrium chloride, whatever, in our water. I don't know if I told them that properly, but I think I understand it. We're saying it is possible to say there is how much is in our solution, and they could now say there's a percentage in it, and if we have 58.44 gram in 1 liter of water of salt, so 58 gram salt in it, then someone could say we have 58 gram salt in the 1 liter water. They could also say there's 0.5% in 1 liter of water. 1 liter of water are 1000 gram, and 58 gram are, if it would be 100 gram, made a mistake, so it's of 5%, 5.8%. It doesn't really matter for what I tell you. It is 1000 gram, so the 5 gram. Whatever the now the comma is the 5 gram, whatever. One could say there are 5% in it, because 50 gram of 1000 are 5 gram. No, it is 0.5. But it's a 50. 500 would be, if it would be 10, so it's a 20, so it's a 5%. So if you have 58% salt in it in 1 liter of water, one could say we have 58% salt in 1 liter. One could but also say there are 5.8% salt in the 1 liter, because 58 gram of 1000 gram of water, 1000 gram is the same as 1000 milliliter, we have 5% in it, 5.8% in it. One could also say there's a mole in it, because it happened to be that 58 gram of salt happened to be the amount of 1 mole of salt, because 58 gram of salt are exactly 6.023 times 10 to the 23 of salt atoms in it. So one could say 58 gram are exactly 1 mole in it, because 1 mole of salt weighs 58 gram, but it are also 6 to the 23, so it's very large number to the 23 of atoms of salt in it. I think I explained it now. No, wasted our language version training, and we're not doing language version training, we're doing body-centered training. That means if you were here for biochemistry, then you can go directly to the next part of biochemistry. We're going to do now the body-centered training. If you stay and participate in the body-centered training, then it's anything else. We have the legs standing hip width apart. We're going a bit down into the knees. Flex the legs and press the legs together. Now straighten one leg slowly. Press together, flex the legs. And straighten one leg again. Press the legs together, flex all the legs. Straighten the other leg. Press the legs together, straighten the leg. Press together, straighten. And bend again and release. Now a bit further apart. Go a bit down into the knees. Flex the legs, press the legs together. And go over to one side. Straighten the leg completely out. Press together, flex the legs. The muscles. Go again back. Press the legs together. Contract the muscles. Straighten the knee. Press together, flex, and take it to the middle. And the next exercise. One leg up. Raising with the leg, flex foot, even at hips taller with the back, and press from the top against the knee. What we don't have done is press from the middle and press with the knee up into the side. And on the other side, press with the knee over top against the knee. So, and over top, to the side. Next foot apart, breathing that down. And breathe out. out. Breathe in, close the legs. And breathe again out. It was a very shortened body center training. I thank you very much. I'll do it next time.